So let's talk about something called object-oriented programming, or OOP for short. Now I know it sounds a little technical, but it's really a powerful way of thinking about code. It completely changed how software gets built by, well, teaching computers to see the world a little more like we do. Okay, let's start with a really big question. Think about it. The world around us is filled with things, people, and all sorts of complicated interactions. How on earth do you translate all of that messiness into clean lines of code that a computer can actually understand and work with? And right here, this is the brilliant core idea behind OOP. Instead of writing one massive, long list of instructions, you step back. You look at the problem you're trying to solve and you ask, what are the things here? Then you build little digital simulations of those exact things right inside your program. And that brings us to the most fundamental building block of OOP, the object itself. A good way to think about it is like a digital twin of something from the real world. So what is an object when you're actually coding? Well, it's basically a neat little package, a container that holds two super important things together. First, it holds the data that describes it, and second, it holds the procedures, which we call methods, that define what it can do. I know, that sounds a bit abstract, so let's make it really simple. Imagine our object is a specific dog, and let's call him Fido. The data about him would be things like his name is Fido, and his breed is Golden Retriever. Those are his properties. The methods, well, those are his actions, like barking or wag tail. The key is that all of that, what Fido is and what Fido can do, is bundled up together in that one Fido object. Okay, so Fido is our specific one-of-a-kind object. But where did he come from? We don't want to have to describe what a dog is from scratch every single time we need a new one in our program. And that right there is where the class comes in. A class is, well, it's the blueprint. It's not an actual dog, but it is the definition of a dog. It's the template that lays out all the rules for what makes a dog, and we can use that template to create as many individual dogs as we want. So our dog class would say, hey, any dog created from this blueprint is going to have a name and a breed. We call those instance variables. And it would also say any dog made from this blueprint will know how to bark and wag tail. Those are the methods. The really powerful part is we write this blueprint just one time, and then we can stamp out as many unique dog objects from it as we need. So, if you boil it all down, it's actually pretty simple. The class is the general concept, the abstract blueprint for a dog. The objects, on the other hand, are the specific, real things you create from that blueprint. Fido, Rover, Spot. Each one is a unique instance of that dog class. Now, this is where it starts to get really, really cool. What if we want to get more specific? I mean, not all dogs are the same, right? OOP has this beautiful solution for this called inheritance. It basically lets us build a family tree for our code. Inheritance is all about code reusability and creating relationships. It lets a new class be based on another class that already exists. When it does that, it automatically gets all the stuff, the data and the methods, from the original class. It's a fantastic way to organize code and avoid writing the same thing over and over. Let's go right back to our dog analogy. We've got our general dog class, which we'll call the parent class. Now we can create a new, more specific class called Poodle, and by simply saying that the Poodle class inherits from the dog class, we've set it up as a child class. It's now officially a special type of dog. So what's the payoff? Well, the Poodle class instantly, automatically gets everything the dog class has. It already knows how to bark and wag tail. We didn't have to write a single extra line of code for that. But on top of that, we can give it its own special abilities, like a unique prance method that maybe only poodles do. It's just incredibly efficient. So let's zoom out for a second. When you put all these ideas together, objects, classes, inheritance, you can start to see why this was such a revolution. Before OOP, code was often just a giant, tangled mess of instructions. This new way of thinking gave us a much cleaner, more organized, and just a more common sense way to build massive, complex software. And really, that's the bottom line. It all comes down to this. By letting us model the real world, reuse our work with blueprints and family trees, and keep everything tucked away in these tidy little object packages, OOP just makes the whole business of programming simpler, easier, and a whole lot faster. So I'll just leave you with this little thought experiment. Just look around the room you're in right now.
It's filled with objects, right? A chair, a lamp, a computer. If you had to build a digital version of your world, what would be the very first object? The first blueprint you would design? It's kind of a fun way to start seeing the world through the eyes of a programmer. Thanks for diving into this with me.